the compilation stages. Okay, so what are the compilation stages we are having? First is pre-processing. Second is compiler. Third is assembler. Fourth is linker. Basically, we are having the this four stages. So basically, what happened in the pre-processing is, if you want to actually what happened in the pre-processing, that whatever the header file we are having and the macro is having, that is that is added in the code, that is replaced in the code. Okay, and how you can check the pre-processing things, you can simply use the -e flag. So what I want to say is, like, suppose you have the file abc.c, then you can see gcc -e abc.c file. It will stop the compilation at the stage of pre-processing. Okay, so by the help of then you can open the the pre-processing file, and you can see that, okay, how this pre-processing basically behave. But in the same way, we are having the compiler. So basically, what the use of the compiler, it converts the dot c file into the assembly instruction. Okay, assembly instructions. And then after, what assembler does, assembler converts the assembly instructions into the machine instruction or machine code. Okay, so now you understand that at the time of the assembler, the machine code come into the picture, or you can say the 0110, like whatever the conversion we are doing, that it come into the picture at the time of the assembler. Okay, so guys, linker basically we use for the actually this is the uh, final stage of compilation, you can say, which actually what happened that it linked the function with the definition. Okay, like the printf statement. Okay, printf statement, right? It is a, like, printf is a function. Now the definition link at the time of the linker. So before that, the printf statement content doesn't execute, or it doesn't convert into the any instructions. This is a one thing. This is a one important role of the print a linker. Now second is the environment variable, right? And we can say the run time at environment environment you know you can say environment creation, you can say, right? Meaning that when you are having the what I want to say here from this point, like suppose you are having the uh, you know the actually we are having the auto file, that is the object file, okay, which we create after the this one at the after the assembler, okay, after assembly created that object file, right, we to run the run the application on the system, okay, we need to provide the environment. We need to provide the environment or setup to execute the application. Okay, so those thing is done by the linker, like meaning that the loader, all the some environment parameters, the you can say the some environment variables it need to pass to the application to execute perfectly. So at the linker, these all things add into the the object file. So that's why the exe file, the executable file, right? When the linker execute it may it create the exe file, that is executable file. You will always say that size of the executable size is larger then .o file, object file. The reason is that exe file is containing the environment variable, the loader for the application, right? The runtime environment creation, right? Printf, the definition, it combine the function to the, not combine, we should use the link the function to the definition, these are the things added at the linker stage. So that's why the exe file become larger than the object file. Okay, so now we will see the everything in the in detail. Also we will what we will do, we will show you, we will write a one program, right, where I will show the pre-processing stages, compiler, assembler, linker, uh, one by one, and so that you will get that, okay, that what happening in the pre-processing stage and the compiler stage and the assembler linker stage, and we will show and I will try to show you that all the concept on the real time. Okay.